Welcome to Try Coding, guys. Today we are going to see the question from lead code 380. Insert, delete, get random, all of them in O of one time. The brief summary of what we are going to do in this whole video is we are trying to find a data structure or make a complex data structure from whatever the data structures that we know of to make it satisfy the requirements that we have now, which is insertion, deletion, and get random access of in time of O of 1. Okay, here is the question or the setting of the problem. We have to implement a class called randomized set where we need to fill three functions: insert, remove, and get random. Insert function will take the value will take value val, and we have to insert it into the randomized set. It will return true or false depending on whether it is there in the set or not there in the set. Similarly, remove or delete, we have to find this value and remove that. And as usual, if it is present or not, we have to return a Boolean variable for that. And finally, we have to implement a random function where we have to select one of the values in this randomized set on completely random basis with equal probability of choosing each of them and return that element. Here, what we want to find is such that each of these functions runs at an average time complexity of one time. Average of O of 1 is what's important here. Okay, first let us understand the question. What does O of 1 or what does big O notation in general mean? Big O is just finding asymptotic upper bound of any function. If you want to define it more formally, f of n is equal to f of g of n when we can find a constant c and n naught such that f is less than c times of g of n for all n greater than or equal to n naught. Okay, uh, here in this graph we can see, let us assume this is f. What we are finding is some function which is above f all the time after n naught. So what happens before n naught doesn't matter for us. It can be f of n that is greater, or it can be g of n that is greater, or anything that can happen. And we have to also note that it doesn't mean that g of n should be greater. It just means that we have to find some constant such that c into g of n is always greater than f. This is what the requirement is. The main takeaway of this whole thing would be f of n goes no faster than g of n. And small food for thought for people who are new to this concept. Can you think of a reason whether we go of 1 by n can exist or not? If it does, why? If it doesn't, why not? Okay, what does average in this context mean? They said we go of 1 on an average, right? Let's take you are in an office and they give you some task. In general, you complete that task in a single day, but everyone has some problems, right? Let's say you have a mild headache on that day. Uh, you won't be able to do it in one day. Let's say you will take 3 days time to complete that. Does that mean that you will take 3 days to complete the task whenever it is given? No, right? You will only take one day, which is on average, will just take one day. On a rare occasion, it goes for 3 days, right? In the same way, we are not concerned about what happens for big things like on drastic scale. You might go there, but it doesn't mean you will always go there. So let's say on this is the example. Okay, coming back to our question, these are the main characters which we have to focus here: insert, delete, and random function. Each of them should be taking average of O of one time, and these are the definitions that are there. Okay, now we will see some of the previous or famous data structures that we have and how they do different things. If you take linked list, it takes insertion of O of one time. We are just inserting at the head or tail, whatever you want, if it is a doubly linked list or something like that. Deletion will take O of one time, given that you already found the node. But since we need to find the node also, it takes O of n time. And since search is O of n, obviously random will be O of n time only. Uh, as usual, the conflict is you don't want random to be n or deletion to be taking n time, right? So this is not accepted. Other one we have is an array. For insertion, we can just say that we will insert at the end of the array. So it will take just O of one time. And getting anything on random inside an array is O of n, since we have indices for this. And deletion takes O of n time, because if you remove the first element, then you have to shift all of the n elements, right? So that's the problem here. You can't do anything. Okay. Finally, if you take an ordered map, you can just insert it in O of one time, delete it in O of one time, but random access is not possible in O of one time. If you don't know what a map is, it's just a table. If you are say inserting val, you will just say val that is there, will keep it as boolean and true. If it is not there, val false or something like that. But we can't find an element at random here, so we have to iterate through the whole table to find some element if you want. That's why random takes of n time. Okay, let's say you go for balanced binary tree or something like that. It's even more worse here, because both insertion, deletion, and randomly accessing some element will take log n time. It's really bad. Okay, what is the solution for this? What we want to do is find a combo of two data structures. In this case, we are going to take array and an unordered map to solve this problem. What does these data structures store? Map stores the address where the value is stored inside an array, and array will just store the values. We'll see through an example how this thing is going to work. Okay, let's first see the insertion. Let's say this is the array we have, and you have got an information saying that you want to insert 4. There is nothing much to think here. Okay, you will insert it at the end of the array, and that's all. And you will also make the changes in the map or the unordered map. Will keep m of that value is equal to at the address where you want to store. Let's say you want to do a deletion. It's the same thing. You just delete. For deletion, what you want to do is we want to delete 2, right? Which is at position 1. We can just copy the last element and keep it here. And now we don't care about what happens to the last element. That's why I have kept a star. It's a don't care. And we will change the position where 3 is stored from 4 to 1. And we will keep m of 2 as -1. Since it is not there anywhere, we will keep it as -1. And if you want to get some random access, we can just call the rand function modulo n, since we don't want to go out of the bounds. And that's all. We will get the index and we will return a of I to be the answer. Okay. Now we will see the implementation. Okay, this is the random class. I have declared the variables, unordered map, array. I have taken 10 power 5 plus 5 because the number of operations can go up to 10 power 5 at max in the worst case, right? That's what I am thinking here. We will initialize number of elements there in the array. Initially it is 0. While inserting, we have to see it is not there in the map. Even if it is there, if it is pointing to -1, it means that it is not there. We will just insert them. While removing, the same thing, we will copy the last element into this wherever this value is stored, and update the place where this lost element is stored. Finally, remove the element which is there, and we have to also change the size of the array. And random, as I have told, we will call the rand function and return a or of that. I have already submitted this, and this is it's already accepted. Thank you.